Hi students, for today's lesson, we have proves the midline theorem. Under that, we have the definition, properties of an isosceles trapezoid, and prove the midline theorem. Definition: trapezoid, a quadrilateral with exactly one pair of parallel sides. The parallel sides are called the bases, and the other pair of sides are called the legs. The base angles of a trapezoid are the angles that include either bases. The median of the trapezoid is a segment whose endpoints are the midpoints of the non-parallel sides. It is parallel to the bases and its length is equal half the sum of the lengths of the bases. The altitude of a trapezoid is the segment perpendicular to the bases. Last, an isosceles trapezoid is a trapezoid with congruent legs. Properties of an isosceles trapezoid. 1. The base angles of an isosceles trapezoid are congruent. 2. The diagonals of an isosceles trapezoid are congruent. Given trapezoid LIFE, the parallel sides of the trapezoid are line LI and line EF. The bases are line LI and line EF. Remember that the parallel side of a trapezoid is also their bases. The legs of the trapezoid are line LE and line EF. Line LE and line IF. The median is line MV, since it connects the midpoint of the two legs. The midline theorem. The segment joining the midpoints of the two sides of a triangle, which is midline of a triangle, is parallel to its third side and is half as long. Remember, the median of a trapezoid is the segment that joins the midpoints of its leg. This is also called the midline of a trapezoid. Let's proceed with the examples. Trapezoid LOVE. LO is equal to 8 and EV is equal to 11. We need to find for line DU. To get the line DU, we have DU is equal to 1/2 times LO plus VE. Since line DU is the half of the line LO and EV. Next, substitute the given DU is equal to 1/2 times LO, which is 8, plus EV, which is 11. And then 8 plus 11 is equal to 19. So we have line DU is equal to 1/2 times 19. And the half of 19 is 9.5. That means line DU is equal to 9.5. Next example. Trapezoid MELO. Given, line ME is equal to 29 inches and line OL is equal to 18 inches. Then we need to find line DY. Same in the first example, we have line DY is equal to 1/2 times the sum of line ME and OL. Substituting, we have DY is equal to 1/2 times 29 plus 18. 29 plus 18 is equal to 47. So we have DY or line DY is equal to 1/2 times 47. And the half of 47 is 23.5. So we have DY is equal to 23.5 inches. Since it has a unit inches, we need to put the unit, which is the inches. Number 3. Given the trapezoid MOBI, we have MO or line MO, which is equal to 216 centimeter, and line LE, which is equal to 186 centimeter. This time, one of the bases is the unknown, which is the line IB. For the solution, we still use the same. We have line LE, or the midline, is equal to the 1/2 of the sum of MO plus IB. By substituting, LE is equal to 186 and MO is equal to 216, it will become 186 is equal to 1/2 times 216 plus the unknown, which is the IB. Simplifying this one, I multiply both sides by 2. So we have 2 times 186 is equal to 2 times 1/2 times 216 plus IB. So 2 times 186, we get 372. 2 times 1/2 times 216 plus IB, we get 216 plus IB. To eliminate 216, we need to subtract both sides by 216. So we have 372 minus 216 is equal to IB. Finally, the IB is equal to 156 centimeter. Next example. Line UA, trapezoid SUAE, with the midline QR. Given, line UA is equal to 29 meters and line QR is equal to 42 meters. We need to find line SE. For the solution, we have QR is equal to 1/2 times the sum of UA and SE. Substituting, we have 42 is equal to 1/2 times 29 plus SE. Multiply both sides by 2. We get 2 times 42 is equal to 2 times 1/2 times the sum of 29 and SE. Simplifying that, we get 84 is equal to 29 plus SE. Then eliminate 29 by subtracting 29 on both sides. We get 84 minus 29 is equal to SE. Finally, line SE is equal to 55 meters. Remember this. Properties of an isosceles trapezoid. First, the base angles of an isosceles trapezoids are congruent. Second, the diagonals of an isosceles trapezoid are congruent. The midline theorem. The segment joining the midpoints of two sides of a triangle, which is the midline of a triangle, is parallel to its third side and is half as long.